Good evening, Sundar sir.
Good evening. Very good evening to everyone. Let me know when we can get started. I think I am ahead of the time, so I can wait. Let me also. Okay.
Comes.
Okay, Rajan, I will make for us. Wait a minute.
I think it should be fair enough to give a 5 minutes break to all the audience, the participants, because they have been with this previous call for more than 1.5 hours. So, what do you think, Dr. Sudha? By the way, am I audible?
Yes, sir. Yes, yes, sir.
I
I
was
will
like,
request Dr. Sendil Selvi, the co-coordinator of this program, to introduce our chief guest, Mr. Sundar Ramamurthy, sir, Principal Data Analytics, Verizon from Chennai, sir. Sendil Selvi, ma'am.
Yes, ma'am. Sir, good evening, sir. We are pleased to introduce Mr. Sundar Ramamurthy, the Principal Data Analytics at Verizon, Chennai. With over 15 years of experience in machine learning and data science, Mr. Ramamurthy has a proven track record of developing and implementing machine learning applications that have significantly boosted business revenue and enhanced user experience. His expertise spans analyzing telecom customer data, cross-channel and digital analytics, supply chain analysis, and human resource management. Mr. Ramamurthy has extensive experience in leading core application and data science team and has worked with cutting-edge technologies including Spark, Python, Hive, Hadoop, HDFS, Data Robot, Domino, Data Lab, and Google Cloud Platform. He is highly skilled in implementing machine learning and statistical algorithms to solve complex real-world problems, including neural networks, gradient-boosted trees, time series forecasting include FE Profit, ARIMA, SARIMA, ARIMAX, and SARIMAX, and optimization techniques using Pulp and Kurobi. Additionally, he has expertise in tree-based forecasting with light, GBM, and ensemble models. Mr. Ramamurthy is known for closely collaborating with business partners, stakeholders, and subject matter experts to plan, develop, store, analyze, and present advanced analytical solutions. As an influential voice in the data science community, he has over 25,000 LinkedIn connections and followers. And his YouTube channel dedicated to data science has more than 1,500 subscribers. Additionally, he has delivered guest lectures at esteemed institutions such as IIT Madras, Anna University, and NIT, where he has shared his expertise on various data science topics with both students and faculty members. Please join me in welcoming Mr. Sundar Ramamurthy. Welcome, sir.
Thank you. Thank you for that introduction. This is very nice. So you covered everything, ma'am. Thank you. Yeah. So let me know when I can get started.
Now you can start, sir.
Yes. So the participants and all my fellow professors. So good evening and namaste to everyone. This is Sundar Ramamurthy and I'm here to talk about transfer learning in computer vision. So and I put on effort even before coming to the session, thinking of. I spoke to Sindhu Selvi ma'am, like whether I should go with all the PPT content or should I go with some kind of a demo and all. So then I decided everyone does the PPT content, but why not do something real time? So I'll make sure that the end of the session you will appreciate this call. And this call, I mean, the content that I'm going to present, this is not this is a partially theory and more like a practical approach. So please pay attention, and then please do ask questions at the end of the session. I'll be happy to answer your question if I know the answers then and there. Otherwise, I will refer back I will take back your questions, and then I will through the ma'am. I will get back to you on the questions that you asked. Answer for the questions. So it is not that I know everything. So it is I'm also in a learning phase, and so whatever I have done practically through the industry level, so I'm here to share that. With that context, let me share my screen. The host isn't allowing sharing for this meeting, ma'am. Can you give me a sharing?
Hello, Marilyn, ma'am. Hello, Marilyn, ma'am. Marilyn, ma'am.
Yes, ma'am. Yes, ma'am. Merlin here.
Ma'am, kindly make the resource person as the host, ma'am. Please, ma'am. Marlin, ma'am. Marlin, ma'am. This is Senthil Selvi, ma'am. Actually, you are host now. Can you make the resource person as the host? Then only he can able to share the screen, ma'am.
Oh, just a minute, ma'am. I'll check.
Yeah. Yes, yes, ma'am. Thank you so much. Sir, few minutes, sir.
Absolutely no problem. I will wait.
Hello, Srinivasa Reddy, sir. Hello. Hello, Srinivasa Reddy, sir. Now you are the host, sir. Please, can you change, make the resource person as host, sir? Melino is wrongly made the host as Srinivasa Reddy, sir. Srinivasa Reddy, sir. Hello, Srinivasa Reddy, sir.
Yes, madam, I am doing you.
Yes, sir. Yes, sir.
Okay, I got it. Thank you so much,
Yes,
Dr.
thank you,
Srinivas.
sir.
Yeah. So screen the entire screen and then the share. Please let me know once you start seeing my screen. All right. So this is about transfer learning in computer vision. And once again, thank you very much for joining. And I'll make sure I'll keep this content, the theory short, and then we'll quickly jump into the practical version of the session. So before going to this transfer learning, whatever we are talking about in the previous session about the CNN or the YOLO and all those image models, right? So basically, what is this transfer learning is all about? Anybody want to answer that transfer learning? Anybody has any answer answer to that? This is an open question. In your terminology, what do you think that the transfer learning could be? Anyone?
Sir, if you are having a very lesser amount of data for the particular application, if you want to move with the deep learning model, we can have the model with trained already with some other large number of data set that will be used for the current application. That is called transfer learning, sir.
Exactly. Perfect answer, ma'am. Thank you. Thank you. So exactly that is the same thing. So transfer learning is, when we're talking about transfer learning, what we are talking about is there is a world of knowledge. The world of knowledge is, take that example of ChatGPT. The ChatGPT has taken all the information that is available in the internet. So it is a petabyte of data, or maybe more than that, thousands of petabytes, or I don't know how much of data it has. So every day it is taking the data from the internet and it is training, and it is having that information as a model. So we call it as a GPT model, or we call, in Google call that as a Gemini model, or Meta, which is nothing but the Facebook, call it as a Llama model. So that is the latest in the transfer learning. So you have everything, the information that is lying in the world knowledge. You have taken all that information, be it whether it's a text information, or it's a image, or it is a video or audio. Let's restrict to this four. So all this information has been taken, no matter what is the format of this data. The text can be, it can be it can be a structured format, or it can be unstructured format, or it could be a semi-structured format. The similar way, the video can be like, it can be like any type of video. It could be MP4 video, or it could be some other type of video or movie file, or it could be anything. Or in the similar way, the images, it could be a PNG file, or it could be a JPEG file, or it could be any other bitmap file, or it could be anything. So all this information, whatever you have seen in this computer, when you go to Google and you see, wait, type something, search, what it gives is, it gives you all the information that is available in the internet with respect to the search, the keywords that you have given. When you go to the image tab, you will see that image related to your search is coming out. Similarly, the next version of Google is nothing but your GPT models, all this Llama model or GPT model, whatever you call. Similar way, prior to this GPT model, we had something called as a computer vision. So basically, what is this computer vision? The recent example I want to give you on the computer, real world application that I want to give you is Kumbh Mela. You take the Kumbh Mela, where you have about, I don't know, like 1.5 crores people who attended it. 1.5 crore or around 2 crore people attended it. So like almost you have a 20 million people who attended this Kumbh Mela. And then what the government of Uttar Pradesh has done is, they use this computer vision. So they wanted to identify where are the congestion, the traffic congestion, so that they can deploy a resource people. The resource people are nothing but the police personnel, so that they can go quickly and remove the congestion from that place. So this was done through the drones, the videos captured by the drones, and because the number of people that the police personnel we have is less for the 20 million people. If you want to go and check where is the congestion, you cannot deploy all the police personnel in every places, every nook and corners. So what they have done, they have used the artificial intelligence, the computer vision, through the drone. The drone will capture the images, and the images will be transformed using the computer vision, and then it will say that if there is a congestion, it will give you an alert, maybe a red signal. If there is no alert, there is no congestion, it will not give you any kind of a signal over there, maybe green. So let's keep it as a red and green. Similarly, if there is a fire, so immediately the fire resource has to be sent there. And we also seen that there were some places there were a fire and there were no loss of life, because the fire the fire department, the officers went so quickly there and they were able to put off the fire. All those things happen using that image recognition, video recognition, or through the computer vision, in short. So what happened is, how does this computer vision knows that there is a fire? So the world knowledge, already the computer vision has been trained with so many objects, so many images, so many videos. And it knows that, okay, if the flames are like, the flames will be like this, it will be in color in yellow, and you can see a smoke there, white smoke there, and smoke, white smoke or black smoke like this. So that means this is a fire. Similar way, take another example. Another example could be, let's take the manufacturing industry. In the manufacturing industry, let's talk about a specific manufacturing industry like automobile industry. So in the automobile industry, you have so many parts. You take a car, the car has about thousands of parts inside that. So which part is what? And this I mean to identify that part, whether it belongs to a like a door, or it belongs to something engine, or it belongs to something called a panel, or it could belongs to something some parts related to electrical equipment. All this information can be trained in the manufacturing industries, and the moment you give a new image to that, or the new audio, or sorry, not audio, the new video or the image, the manufacturing industry will be able to recognize what type of image is this. And so this world knowledge can contain images from various industries, various manufacturing industries, car manufacturing industry. It could be Audi, or it could be our local version of Tata or Maruti, or it could be Benz or anything. Say, okay, so that way it will be able to say that whether what part is this. Similar way, we can use this in the multiple areas like education, agriculture, everything. So that is what you have a trained model, biggest trained model. You have world knowledge there, and from the world knowledge, now you want to know that, okay, let's take the same car example. Now you have this this model. The trained model is already there, pre-trained. We call it as a pre-trained model. Now you have the pre-trained model. Now you want to use. Let's say that you are going to like the Maruti industry want to use this model to identify the parts. So what they maybe the Maruti car parts may or may not be a part of that that particular model. But what they can do is they can take this model, the largest model, and they can send the images of Maruti car parts. It can be like electrical system, or it can be like you are related to something with the wheel, or it could be some accelerator, or it could be like steering, or it could be like something like with your engine. They can take everything, and they can, what they do is you have a world model with all the car parts, and then you have a Maruti parts, the images, which is smaller. This is bigger, this is smaller. What do? You take this and you put this into the largest model. And then what do? You train this model with your parts, so that, and next time what will happen, this large model will be able to understand the Maruti version of parts, so that tomorrow if Maruti wants to do some kind of a image recognition, or they want to use it in training, or say somebody has say there's a new people joining and they want to understand what part is it. So for, let's say, the training cost is about it takes about 1 month for the freshers to understand the parts, and for each resource, let's say they are spending about say 50,000 rupees for training, along with the salary and other things. So let's say that 1 lakh rupees for the training. Let's say that every month they have about some 50 people to train. So about 50 into 1 lakh, which is about 50 lakhs they are investing on the training part itself. So to reduce this, what they can do is they can use this model, and they can they can create a kind of a system. The system will train the team, the newly joined team, so that they can save the 50 lakhs rupees per month investment that is going on. Sorry, the investment that is going on training. So this way, this is the value, business benefit out of it. So now I'm getting into the PPT. So the simple definition I'll just read through is a machine learning technique where the model is developed for a one task. In our case, it is for the automobile industry as a starting point. It leverages the knowledge, the smaller one, the leverage it, in the sense, in our case, the Maruti leverages knowledge gained from solving one problem to help in solving a different. So for example, but it has to be related problem. So I have taken a model which has been trained on the images of the automobile. I can use the smaller images model, which can be used only in the automobile thing. Similar way, if I want to do it for the healthcare, say for example, doctors want to identify the CT scans and the X-ray images or anything like that. So what they can do is they can take those images, and that model trained on the CT scan images and X-ray images, and they can put their images on top of it, and they can train, and that way it will be able to tell that whether this person has what kind of a disease. Okay, so healthcare industry. Similar way in education also you can use it in same way. So if you want to explain this in real world analogy, imagine you learn to identify animals. Say the same example Dr. Anurag was explaining in the previous session with the dogs and cats. So basically this is what you see in the internet also whenever you start doing this computer vision. So I have only two animals. One is a dog, another was a cat. Okay, and my task is to identify the given image whether it's a dog or a cat. Okay, so the model is trained on dog and cat. Now you want to train on the horse. So similarity between dog and cat and horse is nothing but they all are animal. Then it knows that it is an animal. It has a 4 legs, it has a tail, and it has something like the face and other things, the eyes and the ears and everything. Based on that, it will be able to tell you that when you give a horse images, it will be able to tell you that whether it's a belongs to, you are giving a horse, so it will say that most likely it is similar to your dog because the model is not trained on the horses. So initial version will tell you that this is belongs to more or like the most say 50 or 60% of probability with dog. Similar way you give a tiger to that. So the tiger may look similar to your cat. So it will say that this is 60 or 70% looks like a cat. So the probability. So that is where like this is a untrained model. Now what you do, you take the model which was trained on dog and cat, and now you take all the horses or maybe other animals and you classify that as saying that okay, if the image is like this is nothing but a horse. If the image is like this is nothing but a maybe lion, or this is maybe a tiger. So you give all the other 4 different images. It is not only 4 images. You may need to give thousands of horse images with the different shapes, thousands of lion images with different of shapes, and thousands of tiger images with the different of shapes. So this will be converted into a machine learning model. Sorry, not the data, and this will go as an input to the model, and the model will be trained. So now the newly built model, the updated model, will also have the information about cat, dog, horse, lion, and tiger. Similar way, you want to do some rhinoceros or something else, something elephant. So you can do that the same way. So that is what is all about in machine learning, what you do. So normally we use ImageNet or the VVG4 or maybe the mobile net, and there are so many models available like which train with the specific thing. So this ImageNet is basically for learning what it says is whether it is an animal, what type of animal, or and if you want to do. But again, we in real world we won't be using this animal example. So let us go to the next slide and understand more about it. So whatever we talked so far, pre-trained model. So the model has been already trained on a larger data set to classify the image or classify the video or maybe classify the text also, or it could be like anything. If you want me to give another example, there is a loan document. Bank uses loan document which is an image format. So based on the image format, you send all the images to the thing, and based on that, the bank want to take a decision whether based on the information available in the image, the bank want to take a decision whether to approve the loan or not approve the loan. Of course, there are so many ethical considerations we need to do it. This is not so simple, but I'm just giving us an example here. So based on that, you send all the images, and then you say that okay, whether the loan is approved or rejected. Otherwise, if the human wants to do this, probably for one person, he may be able to do 100 application per day, and you want to do it for 10,000 application. So you just divide. So how much people you need? You need 100 people to process the 10,000 per day. So and then you have the cost involved, the salary that is being given, the infrastructure cost and other things, and also the time it takes to process this. So similar way, what you do is you can take any other example, the medical example. Say you have all the images about the X-ray, and the X-ray says that whether there is a tumor tumor in the brain or not, to identify the tumor. So the model will be trained with normal X-rays where there is no tumor, and the X-rays or maybe the CT scan, the images with there is a tumor. So you will be sending about some 10,000 or 20,000 or maybe 1 lakh images or maybe 1 million images to the model, and the model will understand, okay, if the image is in this format, this image, there is a tumor in the brain. So let's assume, keep it simple, it is only about the brain images. So the brain, based on the brain, it says that okay, there is a tumor and there is no tumor in this one. So it will identify what is the probability that this image has a, when you send a new image, it will be able to tell you that okay, this has the probability of say, let's say 60% of having a tumor in the brain, or there is no tumor in the brain, or maybe very less probability. So we may have a threshold. We say that anything above 50% or maybe anything above 70% we may consider as a tumor. Anything which is lesser than 70% is not a tumor. Again, that has to come from the business. In our case, it is all doctors. So doctors will take a decision. What is the probability? They want to keep that as a you say threshold for this. So okay. So you have the all this. So what happens is, when you give all these images, right? These images will be converted into a new numbers. Mr. Anurag was explaining in the previous session, like the numbers. So it will be like a matrix of numbers, where it could be 0, 1, 0, 1, or maybe it could be some decimal values. So it will be converted into, which is nothing but the pixels. So the image will be converted as a grayscale, and the grayscale image will be again further converted into a matrix with all the 0, 1s and the numbers. So you'll see a he was explaining about some 24 by 24, right? So let's say that image has 24. So it is 24 into 24 matrix. So similar way, if you have a bigger image, it can be like a 200 by 200, or if it is a smaller image, it could be 5 by 5. So it is up to you to decide like what size of image that you want to use in your model. So whenever you give an image, the image will be converted into a numbers matrix. In machine learning, we call it as a NumPy array. So it will be like a numerical matrix that will be created. Okay. So what are the applications? Like we have been talking about the application smart cities. So traffic monitoring and management. Let's say that now today we have to deploy the traffic person in every signal, saying that okay, every signal, and then we have to say that okay, we have to monitor this, we have to regulate this traffic. But there are chances that in some roads there may be huge traffic where we need more people, and in some roads there is no traffic at all, but still we deploy the traffic person over there. In that case, so wherever there is less traffic, what we do is we'll take that resource person, the traffic police or the officers, and we deploy them in the places like where most of them were needed. For example, think about the Bangalore congestion. There could be like most of the places it will be congested, but still there are certain roads where you don't need a traffic people. Still it is a outer side. Still it is like a it is like where you don't need a people. It's just a traffic signal will do. Okay. So then real world and e-commerce. Like in real world e-commerce, like it's all like very simple. You also using it. You take an image, you upload it in Amazon, you say that you want to know the price of this. So you take that image, you upload that in the Amazon, you click the image, and then Amazon Prime will get that information. Looking into the image, it will process and it will say that okay, you want this mobile phone, this is iPhone 15, and the iPhone 15 Pro or Max, or this is the price, and these are the colors available. Similar way, you give some other image, like maybe a water bottle. So it will be able to find out like a water bottle, who is selling this water bottle, what is the price, and how much time it will take to reach your home. Okay, and then so that is how like the real world and e-commerce systems are using it. These applications. Manufacturing, I don't want to go much about it because we already talked about this, about the Maruti example, the car example, which we have taken. Other use cases, medical imaging, we talked about it. Fashion industries, wildlife conservation, we have education, and then security and surveillance. And the most important thing is the agriculture. This is my favorite area, the agriculture. You want to see that based on the crop, like if the crop is turning yellow, then you need to pour the water. And what you do, you give an instruction to your, you need to go, no need to go manually there. What you do, you can set up some kind of an IoT device with this image. It will capture the image, it will send it to IoT as a signal to whether to switch on the motor or the water pumping or not. So based on that, it will take the, say, let's say, I don't know about in India how it is happening, but in US and all, there's a large farms are there. In the large farms, like it is mere difficult every day to go and pour water in all the farms. So what they do is they use this IoTs and they use this image recognition to pour the water. The other very famous use case is your self-driving cars. Self-driving car is another very famous one. It is still in development. I don't think it has made some progress, but still it needs to be improved a lot. But it is improving. So these are some of the real-world applications that we see. You may also think something out of this. Maybe in other areas also you can think, like whichever area, the domain, we call it as a domain, whichever domain you want to implement, where there is an image or a video is involved, you may use this OpenCV for the transfer learning. Okay, so now we are coming to the first 3 slides. We covered about the theory part of it. Now let's in real world, let us take a simple example and see how this is working. So let me switch my to my code. So for this exercise, what I have done is I have created a 2-core application, which is nothing but using the OpenCV. Okay, and I try to put some kind of comments also here. So probably I may share this code with ma'am, and she will be able to help you out. And okay, so what I'm doing is I use this OpenCV model, OpenCV Python model, which is nothing but is called as a CV2, computer vision 2. And we also need a NumPy for image processing, converting the image into the matrix. And we also need the deep learning model called TensorFlow, which is from the Google, and Keras, which is a layer on top of the TensorFlow to process these images. So the first thing what we do is we load the pre-trained model here. So we say that MobileNet V2, and then what we do is we load this. We take this model as it is already installed, so it will take Keras.application MobileNet V2, and then we say that we will load this model, and we know this model has a shape of 224 by 224 into 3. Mr. Anurag was explaining the same thing in the previous thing. So this is 224 by 224 matrix, and this 3 is the color channel. So you know that there is a 0, there is a -1, there is a 1, there's a 2, and there's a 2 and 3. So 3 means RGB, red, green, and blue. So which is a color image. So if I want to make it as black and white, then I have to select the grayscale images. But in this one, we are going to use the color images. So this images consist of 224 by 224 into 3. So 3 is not 3 is nothing but the RGB. So the matrix, you can imagine, take the Excel. So in Excel, you can think about 224 column into 224 rows. So that is the data set for one image. Similar way, you have about thousands of images. So that is the matrix that we see. We are going to use this. And this is the pre-trained model. This is a pre-trained model. And what we are doing is, we are taking the base model, and initially what we are trying to do, we are going to freeze this base model, prevent them from being updated during the training. So during the training, I don't want to update this, because I want only during the evaluation or during only the testing phase, I will be giving my own images and then only during that phase, what I'll do is I will be updating the weights and biases for that. So initially, for the train, we set this as a false. So and then we say that the input is nothing but like 24 by 24, and then we say the inputs and the training is equal to false, which we already discussed. And then we have a global thing. I have given the information here. This is converting into a 1D feature vector. And then we use that activation function. If you are already aware of a deep learning, there is something called as activation functions called ReLU, softmax, and we also need to understand that cost function and other things. So like if you are not aware of it, please go and refer the deeplearning.ai site by the Coursera. That is Andrew Ng. There is all the basics of the deep learnings are available there. Deeplearning.ai. Okay. So there's a activation function we use like for the here we have about 2 layers here. One is the global average pooling 2D, and then is the second layer is about dense layer, which is the 128 and ReLU. And my output layer is going to be which has a 10 classes, which is nothing but softmax, which is nothing but, so what it means, I have a 10 class. So this 10 class is basically, it tells you that what type of image it is. Is it image 1 or image 2 or image 3 or 4 or 5, or it is a 10. So for that kind of a classification, we used to have softmax. So we take the model, we initialize the model, and then I created some dummy data here, 1000 samples using the NumPy array. This is again randomly I'm generating it, nothing to do with our images here, because I don't have 1000 image for now for me to take that and process it, because it will take about a day or two to process the 1000 images for me. So when you have the real data, please replace it with the real data set as an NumPy array. Say how do you do that? You can use that NumPy function. You can pass that image as an input, and that will give you as a matrix to that. So that's a very simple 2 or 3 lines code, but you need to process it for 1000 images. Okay, and number of output class I have is a 10. So this is 24 by 24 matrix, and number of output class is 10. So I just randomly generated this. Okay, and then what I'm doing is, so then I know these numbers are generated. Now random image data and corresponding labels are for the training. So generating the images, which is nothing but a random RGB images. It can be anything. Random RGB images I have here. And then what I'm doing is I'm creating this, and this I'm going to, this is my input data set. So now we were talking about that the car manufacturing model, right? Where it has all the parts for all the cars in the world. So, and then Maruti decided to take the Maruti parts and train it, right? So you can assume that context along with this one. So if you already have this, you can give that number, and then what you do is you take the sample, and then you also need to have a validation. So you have a train and you have a test. So for training, you keep something, and for testing, you keep something. So let's say that 80% I keep it for training, and 20% I keep it for my testing, just to make sure that when you are evaluating your model output, whether how much accuracy that you are getting out of your the model that you are recently trained. So based on your images. Okay, now what you do, you compile the model. So compile model, basically what it does is optimize it, use that autumn optimizer for the training, and then we also use the categorical cross entropy by categorical, because I have a 10 classes here. So which is a categorical variable. So that is the reason I'm using the cross entropy here. And what is the metrics that I want to see? The metrics I want to see here is the accuracy. How much accuracy I'm getting here. Okay, and then what we do is we fine tune this train model, say probably the number of epochs, number of training epochs, that is number of times it has to run, execute this, and then what we do is we also now we set this as a trainable equal to 2. Earlier we set that as we froze that. Now we are going to train this with our data, and then this model will be trained. When you say compile, the model will be trained, and then after training again we do the fine tuning. And then what you do is you evaluate the model. Don't worry about the code and all. The code like it's all like easy to understand. So like even you can this codes, everything is available in Google also. Just to like you go through the comments, you will understand this. Don't need to remember all these codes and all, because nowadays with the invention of this GitHub Copilot and other things, you don't need to type in any code. Just you need to say that, okay, I want to do this. It automatically give you the code for you. So what you do is only the concept is important for you. So you understand the concept, and probably you will try with your own data set. So once the model is trained and everything with my data, I save this model as a okay .h5, like there's an h5 model, and then the fine tuning is completed. So you do this. It will take about 10 minutes to train this. So for this model, so let me do this. But what it does is, so let me start training this. I say Python transfer learning train.py file. So there are some warnings. You can ignore this. Nothing. It is not harmful to us. So initially, it will the model with the base model. The weights are frozen. So now the epoch 1 of 5 is starting. So this is the initial base model which I am training. And once it is the base model is trained, we will put our data set, the randomly generated images, on top of it. And what we do is we will train with that, with the weights, the numerical, the numbers that we have, the NumPy array we have of the images, and then these weights will be updated on top of the base model. So base model is nothing but the global model, and the local model is nothing but the base model plus your model. So that is what is your local model. So this local model will be sufficient for you to take this model and use it, apply it in your area. So you think of any area where you have imaging or you have a video or anything, you can make use of it. So let this train, but let's assume this is trained successfully. We'll come back to this. Let me go back to the evaluation. I already trained this model. I can show you that, because yeah, you can see here fine-tune model.h5 is already trained here. This model, if you try to open this model, this is nothing but you will see that model. Okay, we will have all the numbers, but I'll take the risk to open this anyway. I don't know whether this will open or not, but this is a huge numbers. So this is what the model will look like. Your imaging model will look like. Okay, so you will not be able to interpret it, but just for your information, I said this. This is your trained model. Okay, so trained model. Now what I'm doing is I'm going to evaluate the model. So what I have done is I've taken another image. Now we want to validate this model, right? I have taken another image, which is nothing but mycar.jpg. So let's see what is this mycar.jpg is. So this mycar.jpg is a car. Okay, so basically this looks like a Hyundai car here, which is in blue in color. Maybe Creta, or I don't know whether Creta or you have another model, right? Or it could be anything. So I don't know, but this is the model. This is the car model that I see. Now what we are going to do is we are going to take this car and we will pass it to the model, and we will predict that output of it. So the code is very simple. First, the import statement, and here in the line number 7, what I'm saying is I already have a fine-tuned model with the model is already there. So what I'm trying to do is I'm loading the model, which is already saved, which is nothing but this model. This is the file. I'll say that model equal to keras models dot load model. So all the weights and biases will be loaded into this word called model. Sorry, the variable called model. And then I have a custom function here. What I'm trying to do is I'm taking that image and converting into 224 by 224 pixels and RGB in the color as a RGB. So CV2 the color RGB, or I can also say 3 here. Okay, and then I normalize it, the numerical values of it, and then this function I'm passing this file name here and calling this process image and the image path, which is nothing but mycar.jpg. Okay, I have some error handling function here. That's you can ignore. If the image is not available, it throws an error. So, and then you can say make prediction. Prediction equal to model.predict process image. So process image, from where it is coming? It is coming out of my this one. So the process image nothing but this mycar.jpg will be converted as a numerical array, the NumPy array. That is the reason, if you see here, we have the NumPy use here. Without NumPy, you will not be able to do it. So NumPy is a very important library to process all these kind of activities, say for images or anything, because computer has a no vision, computer has a no eye, it cannot see anything, but we have to make the computer to understand how the image look like. So we have to convert everything into numbers, and then what we do is we predict the probability here. So my classes here are, I have a 10 class, right? So my class 0 is nothing but Maruti, class 1 is a Hyundai, class 2 is a Toyota, 3 is Nissan, Renault, Tata, Benz, Audi, Volvo, and Skoda. And then what I'm doing is I'm going to print this and see that what is that probability that we are going to get this. Okay. So let's stop this model. Let's assume that model is already done this. I'm going to kill this because it will take another 20 to 30 minutes and we don't have much time to do that. So what I'll do is I will run that model directly, the evaluation model. Training, let's assume the training is already done. We already have that model outputs, the model weights there. Let's wait and see what is going to happen. Okay, I have a probability of all the classes. It says the predicted class is Hyundai with a probability of 0.17. For Maruti, it is 0.5 probability. For Hyundai, this is. For Toyota, 0.13. More looks like next to the Hyundai, it looks like a Toyota. Nissan is 0.14. Renault is again lesser. Tata is again the next thing is Tata. I think it is getting closer to that Nexon and this Creta, right? So Tata, Nexon, and Creta almost looks like similar. So based on that, it is. And Benz and all, Benz, Audi, and Volvo and Skoda, we have very less probably because it is nowhere near to that that car. So let's see. I also printed the image here. Earlier you saw that the image was in blue color, right? Now you see there's a red color. We changed the color to red, and you can see here it is saying that this is a Hyundai with 0.17 probability. Okay, so this is the very simple example of how this image classification is working. Similar way, think about if you have some medical field where you want to identify the disease or you want to identify some devices. Say there are so many medical equipments are there for for new recruits students. If they want to know that what is scissor or what is scalpel or what device is used for what, to train them, it is like there is some surgical experience person needs to be there, always needs to be there to explain them, okay, this is the scissor, this is scalpel, or this is something else, so you have to use for this one or that one. So instead of that, they use this kind of a model, so probably they'll be able to understand this without any human intervention. Okay, so let's go back, let me close this and go back to this one. F5. Okay. So some of the challenges and limitations, every model or every domain has some challenges and limitations. So domain mismatch, say for example, the domain mismatch, say for example, I created a model with the automobile industry, and if I want to use it in a medical industry, probably they may not work. So you have to define another the model which was trained on the images with the medical images. So you cannot use that images, the car images, to categorize the medical images. overfitting. Small target data set may lead to overfitting. So for example, overfitting means while training, it may say okay, 90% accuracy, 70% or 80%. So it will work fine because training has a lot of data set. But when you are going to actually evaluate it, like the way we did, instead of saying Hyundai, it will say Audi. So it will give a wrong interpretation to that because we don't have so much of Hyundai images. It may not be able to interpret Hyundai properly. So it will say that instead of Audi it is a Hyundai, or it will instead of Hyundai it will say Maruti. So that is the based on the target data set. You need to have optimal number of target data set. That is another important. Computational demand, you need a GPU capability. So in this case, I have a limited GPU and I don't have a much data set because I use the mobile net, and which is a smaller model to explain the concept. But imagine you have a billions of images, you want to process it. So in that case, you need to go for A100 or H100 or maybe with so much of larger GPUs with the processing power. So that computation, storage computation, data, vast data, and then you also need the resource, the power of computer. So everything is needed there. Feature misalignment. Okay, the same thing what we explained about the domain mismatch. The features that we are creating, like we have 10 features, right? What if there is a new car? Let's say that, okay, let me think about. Okay, we covered all the 10. Let's say that there is a new car called Datsun Go. Okay, we don't have a Datsun class at all. We have only the 10 classes. We don't have a Datsun. So if the Datsun car is coming up, probably there's a feature misalignment. In that case, we need to have Datsun car images, and we need to train that. Or maybe if we have a truck, or we may have something like Ashok Leyland trucks, or maybe Tata trucks. In that case, the feature misalignment can happen. So again, we need to think about how do we adjust this model. And bias in model, let's say that the pre-trained model itself is giving a not giving a sufficient accuracy, and then you take that model and you train it for your purpose. So if the bias is nothing but the error, the source model itself is having error, that error will be transformed to your trained model as well. So that can also be possible. And the model size, again, the large models are difficult to deploy. Okay, when you're talking about deployment, you need to deploy it in some server. So when you have a huge model, think about like GPT models, or you think about Llama or something, you cannot deploy it in one server. You need maybe a data center, a huge data center with a data lake, which can be huge investment for you. So that is also another challenge that we have. So how do we talked about challenge and limitation? How do you mitigate this? So use the domain adaptation. Make sure that you use the smaller model according to your model. It doesn't mean that larger model will perform better and smaller model will not perform better. Sometimes for our requirement, sometimes smaller model may perform better. And data augmentation also, like when you're taking the data, it needs to be augmented. And then the fine tuning, when you're doing a fine tuning, you need to have an optimal number of hyperparameters tuned one. Like we call it as a learning rate, and then the number of epochs and other things, right? So you need to see that what is the best hyperparameters that you want to tune. And once you do this, like you may get a better, I'm not saying 100%, but you may get a better results. Okay, thank you. With this, we are at the end of this session. I'm open for the question and answer. Ma'am, back to you. Hello, ma'am, back to you. Hey, can somebody
Dear participants, if there are any doubts, ask to Sir Sundar sir. She is ready to answer your questions. Any questions from audience? Any questions from audience? Any questions or shall we close the session? Any questions from audience?
Sir, how can we add the explainability to these functions or these models?
Yeah, that's a very good question, Dr. Kritika, if I'm right.
Yes, sir.
See, deep learning model explainability is a very challenge because this is a black box. So, simple model, we can do the explainability, how it is doing. But this is deep learning model which consists of so many layers. You have the input layer, you have an output layer. That is a constant. And in between, you can have a multiple layers. Anurag was saying, right? You have a layer 1, layer 2, layer 3, layer 4. So what this deep learning model does, the layer 1 is, it will take the feature from the each, and so let's say you have 10 variables in the input model. It will take, let's say you have a customer age and you have the customer income, and let's take two things. So it will take the age, and from the age, it will create some 10 features. And these 10 features in the layer 1, these 10 features will be sent to the second layer, where this will be created as 100 features, minute features. And then let's say you have a third layer, so this 100 will become 1,000, and then this 1,000 will go to the model as an input, and then the output is derived. So deep learning model, still people are working. This black box model, still people are thinking about how do we do the explainability, create explainability. There are certain papers and articles available, but being in this industry, I didn't see any substantiable explainability model like we have this one, right? Lime, SHAP, and other things, right? Which can be good for random forest, XGBoost, and other things. Any tree-based models. My thing in two areas where the explainability is not possible is, one is the time series model. Time series model explainability, though we can say that there is an explainability, but the domain specific explainability is not possible. And the second thing is the deep learning model. So still there are research papers are there, but ma'am, it is not even something which we can consume it in our real world. So I'm giving the perspective from the real world perspective. The articles and papers are available, but those are only in the academic area, ma'am. Did I answer your question, ma'am?
Yes, sir. Yes, sir. I have worked with Lime and Ship, and
Yes.
basically for the earlier models, like you said, the random
traditional models,
forest,
random forest, XGBoost, like GBM,
yeah,
all those things will work fine. But
yeah, that's what I am asking, whether it is somewhere for transfer learning there is explainability models available. Thank you so much, sir, for answering the question.
You're welcome. Thank you for the good question.
Participants,
Yes,
any more questions?
Please do ask question. I will learn from your questions.
Hello?
Yes, sir.
Sir, how can we interface transfer learning with GAN model, sir?
Transfer learning with what model, sir?
GAN, Generative Adversarial Network.
Okay, this is the area like which I haven't worked on it, sir. So right now, honestly, I don't have an answer for it. Probably I'll check this with my colleagues and I'll get back to you, sir, if it is okay.
Okay. Thank you, sir. Thank you, sir. No problem.
Yeah.
Any questions from participants, or shall we close this session?
Maybe we can give another couple of minutes, ma'am. Maybe thinking.
Okay, sir. Yes, sir.
Yeah, we give a couple of more minutes for the participants.
Okay, sir.
Okay. If you don't have any question, then thank you very much for joining. Ma'am, back to you.
Thank you. Okay, sir. I call over Sundar Ramamurthy to deliver the water funds.
Yes, ma'am. Yes, ma'am. Thank you. Good evening, everyone. On behalf of the Department of Computer Science and Engineering at SRM Institute of Science and Technology, I would like to express our heartfelt gratitude to Mr. Sundar Ramamurthy for gracing us with his invaluable insights during today's session on transfer learning in computer vision. Sir, your expertise and deep knowledge on the subject have truly enriched us. The way you explained the concepts of transfer learning and its real-world application in computer vision was both informative and inspiring. We appreciate the time and effort you have taken to be with us today, and we are certain that the participant will leave with a deeper understanding and new perspective on this transformative technology. I would also like to thank all the participants for joining us today. Your enthusiasm and engagement throughout the session are greatly appreciated. I hope that you found the session insightful and that it will contribute to your future endeavors in AI and deep learning. Once again, thank you, sir, for being with us, and we hope to have the opportunity to host you again in the future. Thank you, everyone, and have a great evening. Thank you, sir.
Thank you so much, sir. And dear participants, once again, thank you all for your active participation in today's session. Tomorrow we are having two more experts, Mr. V. Rajeshwaran, Senior Director, AI Futures and AI Center of Excellence Head from Capgemini, Chennai, and Dr. Badri and Subhadi, Associate Professor and Head from Department of Electrical Engineering, Indian Institute of Technology, Jammu. Then we will meet tomorrow 6 p.m. for day 3 of this faculty development program. Then the feedback for the session 4 is shared in the chat box. All are requested to submit the feedback before leaving the meeting. Thank you, Nadu.
Thank you, and have a very good day.
Thank you so much, sir.
Thank you, sir.
No, Sundar sir, make me as a host and lead the.
Yes. That's what I'm saying.
Okay.
I'm looking for your name there. Yes, I see this.
Okay. Thank you so much.